Hey everybody, thank you so much for coming tonight. So as you can see up on the screen, tonight's webinar is going to be based on combinations and permutations. Like most of our webinars, which are based on some of our different chapters from our curriculum, there's a lot of content to cover. So between Scott and myself, we certainly like to focus on certain components of these chapters, and given that there's a lot more webinars that we'll be doing in the future, we're going to get to certain topics that perhaps we don't cover in the 1 hour that we have here today. So my plan in the first 30 minutes is to do a lot on combinations. And before getting started, just a few thoughts on combinations and permutations. For one, this is the topic that if you talk to people that have taken the GMAT before, read some forums, people will say this is the one topic you can skip because you won't see a lot of it. Generally, that's probably not a good rule of thumb to take. I mean, certainly, if this wasn't a topic on the GMAT, it wouldn't be something, we were covering tonight and wouldn't be in our curriculum and things like that. The second thing is the notion that there's, the big challenge with combinations and permutations is to know when you're dealing with a combination versus a permutation. And I was once a student, and I had this preconceived notion as well, and I feel like I ingrained it into my head. So when I was getting to these questions, I too felt like that was one of the major issues. But as you do a lot of these problems, and remember, we have, I don't know the exact number, but it's close to 100 combinations and permutations, and I guarantee you that when you get through all the questions we have in our curriculum, there won't be a question of, how do I know I'm dealing with a combo, which is a combination, or a permutation? So tonight I'm going to be focusing a lot on combinations, and I'll talk briefly about, some of the kind of key words or key thoughts or situations that's going to allow you to know when you're dealing with a combination. So the first thing that I just want to talk about as it relates to combinations, and you hear this a lot, is that, order doesn't matter. But of course, that has to make sense, because we could say that till we're blue in the face, but if you don't know what that really means, it's not going to be too helpful for you. So when we say order does not matter, the first thing that comes to mind in my eyes is you want to think team. Now, I'm saying that because when you select a team of individuals, it never really matters what the order of that team is. The team will always be the same. So if Abby, Bob, and Tom are selected on a team, or Tom, Bob, Abby, it's the exact same team. Thus, order doesn't matter. It's only when there's specific positions going on the team when order would matter, and thus it would change the arrangement, and that's a permutation, which is something that we may get into later tonight. So this is a small nugget. I want you to keep this in mind. These are things that you can memorize. And remember, when I say think team, you can visualize these things. I think about, being on a playground and getting picked for a kickball team, and how it doesn't matter when and if you get selected for the team isn't going to change regardless of the order arrangement of it. Now, tonight, too, and for those that have dived into our curriculum here, there's two ways of solving combinations. We have one method, which is the combination formula, and another one, which is called the box and fill. I'm going to be using the box and fill. It's my preferred method. There is nothing wrong with using the combination, equation, but for the purposes of going through solutions, you'll notice that I'm using the box and fill. If you're not too familiar with it, I'll explain it briefly during the first solution. But we have a chapter chock full of this stuff in the curriculum, which I know the majority of you have anyway. So I want to start off tonight with a basic combination question, and to kind of belabor the point I just made, we can confidently say that we know this is a combination where order doesn't matter because we're dealing with a team. And so, you'll see tonight with the questions I'm giving you, you can kind of keep that little nugget in the back of your mind. So I'll give everyone about a minute. minute and a half, and then we can kind of go through the solution here. Okay, so that was about 2 minutes, and I forgot to mention this, but as everyone gets their answer choices, feel free to plug it into the public chat so everyone here can see what you're getting, and you know, I can see what you're getting as well. So this is probably the most basic type of combination that you're going to get on the GMAT. It's where there's a single event taking place, and obviously, there's steps you want to go through in your head, like I was saying before. The first thing is you need to know it is a combination. But the minute we see team, we know that order's not mattering. We know we're dealing with a combo. So the way that I like to kind of denote the information, and we talk a lot about this in our chapter, especially at the beginning, is I like to use the big C. And for those of you who are, well, hopefully there's not too many of you in your mid-30s like myself, but back when I was taking a stats class, you know, on your scientific calculator, you could basically, you'd see that big C button, and that would stand for combos, or for a combination calculation. So what we do is we have some subscripts here where we will put something that goes here to the left and something that goes here to the right. Now, the thing on the left is the total number of possibilities that you're selecting from. So as you read through this question, a coach must select 3 softball players from a pool of 7. So what we put here is the 7, and that's just a placeholder, so you know there's 7 total people. And then we know that we have 3 spots. So that's where we put the 3 on the right side of the C. Now, where I may differ from some of you is I'm not going to take this and put it into the combination equation. I'm going to do what we call the box and fill. To save time, though, instead of doing a full box, I'm just going to put a kind of line that represents a position. So the idea behind this method is it does save a little bit of time and a step from the combination formula. And the way it works is pretty simple. You know you're dealing with a combination. You know that there are 3 spots available because we're choosing 3 players. So you draw out those lines. And then you say, okay, well, how many players do I have available for the first spot? And you say 7. How many for the next spot? Well, you have to decrease it by 1 because we assume 1 player was selected, so there's 6. And then finally, 5 for the last spot. Now, the only final step here, because you're dealing with a combination, you take the number of boxes or slots or lines that we created, which is 3, and you set that to a factorial. Notice once again that that matches that subscript on the right-hand side of the C there. And then, you know, the smartest way to go about this is to reduce before multiplying. 3 factorial, which is 3 times 2, will reduce with the 6. and we're left with 35. So that is, as I said, probably the most basic combination that you're going to get, on the GMAT. Now, what I want to do is I want to start putting us in a situation where you can see multiple combinations. But before we get there, we're going to talk about the fundamental counting principle. But now, instead of me explaining it, what I would rather do is give everyone a problem that tests this idea, and then I can explain it kind of on the back end once we go through the solution. So that's what I'm going to put up now. I'll give everyone a minute or two. Then what we'll do as I start seeing answers come in is talk about this and then increase the difficulty of some of the combination problems that we're doing. Okay, so that was close to 2 minutes here. As I was saying, what this problem is testing is something called the fundamental counting principle. And the best way to kind of think about it is that the fundamental counting principle is calculating decisions. So what we have here is we're given that there's a sandwich shop, there's 3 types of bread, 4 meat, 5 drinks. And we want to know how many ways a tourist could put a meal together, given that a meal is 1 of each. And this could be, there's a million ways to see this. I know we have a question on someone picking out an outfit of belts, hats, and shirts. So it can be adjusted in many different ways, but the idea is you're taking each one of these decision points, the bread, the meat, and the drinks, and you're simply multiplying them together. Now, of course, there's 3 bread, 4 meat, 5 drinks, and we're going to end up with 60 as our answer here. This is important, and although you probably have done problems like I'm going to show you in a second, the reason why in a lot of combinations when there's multiple events happening or multiple decisions taking place that must happen, you multiply them together. It has to do with this whole idea of the fundamental counting principle. So what I want to do now is I want to take this idea and blend it with the first thing that I showed you, and you're going to see how these can get more and more difficult. The good news, though, about this is that this stuff, although it's going to seem like it's getting more difficult because it's more steps, the general idea of what I'm going to be showing you is not going to be all that bad. So that's the really good news. And I think, again, as I said, there's this notion that these combo problems are so insanely challenging. And I think once you kind of have some basic rules and principles together, it's not that bad. So let's start with this question here. And, we can talk about this, but keep in mind this is going to be a combination of the first few things we did, or a hybrid of all that. Okay, so I see we have a few answers that came in here, and those are the correct answers. So as I get into these types of combination problems, I create, at least mentally, what I call buckets. And I have buckets, you can call them categories, that's another way to think about it. But the reason I do that is because you have to separate everything that you're working with. So you'll notice here that you have two buckets or categories. I say you have the cheese bucket and you have the veggie bucket. So those are also the decision points that I was referring to back with the fundamental counting principle. And that's why we're going to have to add the number of ways we can do the cheeses times the number of ways we can get these veggies. And of course, they're also giving us some specifics about that. So the first thing we see here is that we're saying you can choose, or we need to choose 2 cheeses from a total of 4. So as I showed you in the first question, that's going to be 4 choose 2. The veggies, there's 3 total veggies. We're choosing 1. So that's 3 choose 1. Now, a little kind of nugget here is that if you ever have, something choose 1, the something, quote unquote, is always going to be your answer. So 3 choose 1 is 3, 10 choose 1 is 10, a million choose 1 is a million. So there's not really much you have to do here. You can just say that result is 3. And then finally, what we can do next here is we have our box and fill. We know that there's 4 to start. There's 2 spots, so of course we have 2 slots here. We do 4 times 3. We divide by 2 factorial. That gives us a total of 6. 6 times 3 is 18, so the answer is C. So I want to do one more of these guys, make sure everyone has this down before I venture into some things that are a little bit harder. So why doesn't everyone take a stab at this question here, and give you 2 minutes and we'll talk about it. Okay, so that was close to 2 minutes. So I see we have some good answers here, and the answers put that were in the chat box are correct. And hopefully everyone's seeing, okay, the problem we did before this was cheese and veggies, and now we're just dealing with juniors and seniors. So there's nothing crazy going on here. They can change the display. They can change the categories or the buckets, as I like to say, but it's the same stuff. And, that's the GMAT in a nutshell. It's the same stuff asked in many different ways. So when we look at this problem, the first thing I'll kind of denote is saying, okay, I know we have seniors. I know we have juniors. and we attack the seniors first. We see that the teacher needs to select 3 seniors, and there's a total of 10. The only slightly annoying component of this problem is that the math can get slightly large, but based on the answer choices, once you get the selections down for seniors and juniors, it's not hard to come up with that answer. So we see for the seniors that we're doing 10, choose 3. Notice 2 juniors from 8, so that's going to be 8, choose 2. Now, if we do the box and fill, there's our 3 slots, 10 times 9 times 8, divided by 3 factorial, which to save a little time, I'm just going to write 3 times 2. And then we just do the reductions. 10 times 3 times 4 is 120. And then we have 8 times 7. There's our 2 slots. We divide by 2 factorial, which is 2. Then we divide, then we reduce. 2 goes into 8 4 times. We're left with 28. And our answer is 3,360 when we do that math. So 2 problems, very similar idea, just different situations going on. So I want to kind of step up the level of difficulty here. And this is a similar problem, but you're going to see there is one slight difference. So I am very interested to see the answers that people give for this next problem here, and just start plugging them into the chat box as you get them. Okay, so I see there are a few correct answers here, and you know, for those of you that are a little confused on this problem, hopefully I can shed some light onto the similarities of this problem versus the other ones we did. So in the last 2 problems, we were pretty much straight up given the 2 categories that we were working with. You know, cheese and veggies, it was pretty obvious, pretty straightforward. Juniors and seniors, it was pretty obvious, pretty straightforward. Well, now all of a sudden, this is a little less straightforward. There's a little bit more gray area here. And although we're choosing 5 items, we're only told that we are getting 3 rubies. So the first thing you have to think of is, okay, well, if we're telling us to choose 5 and only 3 of them are rubies, well, the other 2 have to account for something. So the buckets that I create here is I do the rubies in one bucket, and then I do the non-rubies in the other bucket. You might say, well, wait a minute. I see that there's emeralds and that there's diamonds. Well, the fact is those are the non-rubies. So we don't need to classify those specifically because the problem doesn't ask us to select emeralds or select diamonds. It says that we're getting 3 rubies, which means we have to get 2 non-rubies. So if that was a hurdle for anyone to get over, make sure you look at this again later. This is a problem that I think is starting to creep up into the mid to high 600s just because it's not as straightforward as the combinations we did before. So now after, figuring that out, which is probably 65% of the battle, we just have to fill in now. Now we know that we have 5 rubies, and we know that we're selecting 3 of them. So if we do the box and fill question or method, we are going to say 5 down to 4 down to 3 divided by 3 factorial, which is 3 times 2. That cancels. That becomes 10. Now for the non-rubies, there's 4 emeralds, 3 diamonds. That's a total of 7. We know we're selecting 2. 2 slots here, 7, then 6, divide by 2. It's going to give us 21. 10 times 21 is 210. Now, we will get to this in time, but, one thing I want to mention really quickly is that, a lot of these combinations that we're going to be doing tonight and have done can be converted into probability questions. So for any of you who are, getting to this part in our curriculum, you'll see we have a whole section as well on probability and how that can be solved with, using these types of combinations and things like that. And the good news is, if you can do it with a combination, you generally can do it within probability. Now, obviously, I'm getting ahead of myself a little bit. There's still a lot of good stuff to be learned here, but just keep that in mind for anyone who's still working their way through the curriculum. So with that said, Scott, I'm going to pass you the ball here, and you should be able to get going.
Okay, great. Thanks, Jeff. How's the audio?
Audio is great.
Good. Good. Hey, everybody. Thanks again for coming out tonight. So what we're going to do here in the second half of the hour is look at some more basic permutations. And depending how these go, we can also perhaps look at some more difficult ones. And as Jeff told you, none of these guys are really difficult. I think sort of history makes things difficult when I mean by that is like I remember learning these guys in like high school, and like my teachers would give me like problems, and they'd ask me to do like 14 variations, and it's just a class to teach, and same thing with there's most sort of like test up, structures. They give you 3 or 4 problems, and then they ask you to do like 14 variations. But what the key is to make sure that you see a number of different ways of looking at these guys, and from there, the problems get really easy. Okay.
Hey, Scott?
Yeah.
Your audio isn't sounding so good.
Okay. Perhaps it's the same problem as last week, Jeff. If so, I can unfortunately have you take it away. I can't really. There's not too much I can do to the same connection here we have. You want to take it away?
Yeah, that's fine.
All right, guys. Say I'm really sorry. This is 2 in a row. I will see if I can get this worked out. So Jeff will continue to torture you with permutation.
No problem. Okay, so guys, I'm actually not going to do permutations, lucky everyone. So I'm actually going to continue with combinations. So what we're going to start with is we are going to do a combination that deals with adding instead of multiplying. Now, I am going to explain what I mean. Scott, just so I can take the ball back, it looks like. I'm going to explain what I mean in a second. So I want everyone to first try this problem, then we're going to kind of talk about what all this means. Okay, so hopefully everyone noticed, a major difference between this problem and the ones I was doing previously. And one of the, well, not one of the, but the major difference is you can see blatantly that the word or is used. Now, this is kind of a gift. They're not always going to give you this quote-unquote gift. Sometimes it's going to be more implied, but for the purposes of this problem, we can all be very happy that we have this. Now, what that means is that instead of using the fundamental counting principle in the way that we dealt with it before, we're not going to be we're not going to be multiplying these things together. We're going to be adding them. So what we need to do here is first we need to get our buckets or our categories. We have our coins, we have our jewels, and we have our daggers. And what we're going to do is set these up. So 4 different coins, 5 jewels, 6 daggers. It's 2, 2, and 2, which makes this a little bit easier. So for the coins, we're going to say 4 choose 2. 4 times 3 over 2. That's going to give us, and we'll write it down here, that's going to give us 6. For the jewels, we have 5 choose 2. 5 times 4 divided by 2, that's going to give you a 10. And then for the daggers, that's 6 choose 2, our 2 slots, 6 times 5 over 2. That's going to give us 15. And I don't know why I put a multiplication sign there. It's actually an addition sign. We add 15, that's 31. Now, pretty easy, right? So what I want everyone to start getting in the habit of is thinking about when the word or the idea of it is implied, and I like to use the term scenarios, you're going to be adding. And this is important to keep in mind. As I said before, this is important for probability. And this is certainly important for a lot of the combinations that we're going to be doing moving forward tonight. So with that said, I am actually going to step the level up to what is probably considered a 700 level question. And what you're going to find is it's really not that bad. It's just taking a lot of the things that I've shown you here tonight, and it's combining it into one question. So my whole thing is that if that's what a 700 level question is, I'll take that 10 days out of 10 because there's nothing crazy and new I have to do. It's just a matter of doing the math correctly and organizing the information. So why doesn't everyone start this? I'll give everyone about 2 minutes, and then we can go talk about it from here. Okay, so that was about 2 minutes. I see we have one answer here, so I hope that many of you were able to get close to the answer. The thing to notice here is there's no addition will be a part of what we do here, and you'll notice the word or is not used at all. So as I said, this is not a layup like the last problem. You're going to have to look at it and say, well, I see the word at least 2 Iranian players. So that means that there could be 2, there could be 3, there could be 4. Those are scenarios. The reason I stopped at 4 is because it's saying it's composed of a team of 4 people. So with that said, we need to create these different scenarios. So scenario 1, in my eyes, would be 2 Iranians and 2 Turkish people. Scenario 2 is 3 Iranians and 1 Turkish person. Scenario 4, not scenario 4, scenario 3 is 4 Iranians. Now, obviously we have to do the math here. Now what you'll notice is you could almost look at each scenario as an individual combo question. So back when we did the cheese and the veggies, well, that's exactly what's going on here. That's exactly what's going on here. Or you could think back to the junior-senior problem. So like I said, this is 700 level because there's many steps, and someone starting out in combinations is never going to get this. But if you know all the bits and pieces of these questions, they're not that bad. So we say, all right, 2 Iranians. Well, we know that we have 6 of them. So that's 6 choose 2. We know that there's 5 Turkish people, and that's 5 choose 2. So if we do our box and fill, 6 times 5 over 2, that's 15. 5 times 4 over 2, that's 10. That's 150 for starters. Scenario 2 is 6 Iranians. 6 choose 3 is 6, just write this out, times 5 times 4 over 3 factorial. Keep in mind that's 3 times 2, so that cancels. 1 Turkish player, there's 5, so that's 5 choose 1, which is of course 5. Multiply that together and you get 100. The last thing we have to do is 4 Iranians. We know there's 6. 6 choose 4. 1, 2, 3, 4 slots. 6 times 5 times 4 times 3 divided by 4 times 3 times 2. Everyone keep in mind that I'm reducing before I multiply. That's really big. I mentioned it earlier, but always make sure you do that. Add everything together and look at what you get. 150 plus 100 plus 15. That's going to give us 265. So what I want to do is I want to show everyone a variation of this problem. Now, I'm not going to tell you what the variation is, and everyone can solve it any way they want, but it's going to seem like a similar problem with one slight difference. And then we will talk about that. And then we'll get into some more nuanced combination problems. And, we will probably get close to the end there. Okay, so everyone take about 2 minutes and work through this problem here. Okay, so this is very, 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 very similar to the last problem. There is one major difference, and instead of it saying at least 2 players from Iran, we see the word at least one. And obviously, we could do this the same way. We could go through the scenarios of 1 player from Iran, 2 players from Iran, 3 players from Iran, and then 4. But that's going to take a while. Obviously, the more scenarios you do, the more potential you have to make math errors. And once you make a math error in a problem like this that is lengthy by nature, you're pretty close to not being able to fix whatever math error you make. So to kind of get into this a little deeper, understand that there's only so many scenarios that can happen. So if we say, 1 Iranian plus the scenarios with 2 Iranians plus the scenarios with 3 plus the scenario with 4, and plus the scenario with 0, I should have put that at the beginning, that equals the total scenarios. So what is being asked in this problem is, what is the sum of, and I'm going to highlight it, these 4 scenarios here. So if we're all thinking strategically, why not just get the sum of, why not just get the total scenarios and subtract from the total scenarios 0 Iranians. That's going to equal this, which is exactly what the problem is asking for. And to me, that's a much easier, more efficient way to do 2 things than it is to do 4 things, and I think most of you would agree. Now, the key with doing it here versus the last problem is when they say at least 2, working backwards like this, to me, isn't quite as worth it, because you still end up having to do more than 2 scenarios. So I would say do the last problem the way we did it, and do this problem where you do the total minus 0 Iranians. The key, though, is when you're seeing total scenarios, there's no restrictions, there's no buckets, there's no categories. So what I mean by that is we know that we have 6 Iranians, 5 Turkish people, so that's going to give us 11. So 11 choose 4 is the total. Now, let's do that math out first. So if we're doing the box and fill, here's our 4 slots, 11 times 10 times 9 times 8. We're dividing by 4 times 3 times 2. Strategically, we can get rid of these. So what we end up with is a grand total of 330. Now, of course, if we're doing 0 Iranians, which we'll put that in red, what that really means is we're doing all Turkish people on the team. So we know that there's 5 Turkish people. We're selecting 4. Another nugget that I wanted to give everyone is that just like if you have, well, let me put this to you a different way. If the value here on the left-hand side of the C is 1 greater than the value on the right-hand side of the C, you don't have to do any math out. The answer is going to be 5. So 6 choose 5 is 6. 10 choose 9 is 10. 100 choose 99 is 100. Why am I saying this? Because this is going to make your life easier. The final step is taking 5, subtracting it from 330, and that's going to give you 325 as your answer, which is answer choice D. Okay, so what I want to do is a couple more nuanced combo questions, things that are going to be pretty important come probability time, which I keep bringing up, and very curious to see how everyone handles these questions. And the 2 I give you are going to actually seem almost identical. They won't be, so just keep that in mind. But the first one is this here. Take a stab at it, and then we will discuss. Okay, so this is an interesting type of problem that once you kind of understand it, you're gonna be able to do it in a cinch. And there's two ways to look at it. I'm gonna give you kind of the faster way that I tend to look at it, and then I can give you a slightly more longer-winded way, which is a bit more technical, but both are obviously correct. So normally, if Alex and Eric weren't involved and they just said, how many ways could you select this team, we would just say, well, there's 8 students, there's 5 people, so it's 8, choose 5. But, it's not 8, choose 5 because there's things going on with Alex and Eric that we have to account for. And that's the second sentence. So we are told that Alex and Eric must make the chess team. And then it's saying in how many different ways can the chess team be populated or created. So if they have to make the chess team, what that means is the 8 spots that we originally have goes down to 6 spots. Or excuse me, 8 students that we're choosing from goes down to 6 students. And then the 5 spots that we have available goes down by 2 to 3 spots. So instead of this being 8, choose 5, this now becomes 6, choose 3. If we do the box and fill, we have 6 times 5 times 4 divided by 3 times 2. The answer is 20. So, you could look at this as categories or buckets and say Alex and Eric are one bucket or one category, and then the other students are another. But my thought is, since we know they're being chosen, let's just reduce where we need to in this, in the combination. So we reduce it from 8 to 6 and from 5 to 3. So what I want to quickly do before we wrap up, everyone, is do one more kind of slightly different version of this problem, and then we can wrap. I'm also going to put the feedback form in the chat box, so everyone feel free. We'd love to continue to get your feedback. And just to make another announcement, continue to save, all of your information on the Target Test Prep site because we will be switching to the new site really, really soon. So last question here. Everyone take a stab at it, and we'll go through the solution. Okay, so that was about 2 minutes there. So hopefully everyone is not looking at this and saying, this is the exact problem I just had, but you're looking and saying, well, I see a slight difference. And there is a slight difference. Instead of Alex and Eric making the team, they're not making the team. So if we say without any of these restrictions, we have 8 students, and we have 5 spots. Notice that because Alex and Eric are accounted for, we do reduce 8 students to 6 students. Because again, we've accounted for them. They're not part of this team. We know they're not, so they can't even be selected. But the 5 spots remains 5 spots because they did not take up any positions on the team, leaving us with 6 students for 5 spots, giving us 6 choose 5, and the answer here is 6. So with that said, everyone, I hope that this was good for everyone tonight. I hope you were able to learn a lot. Like I said, in an hour, this is just scratching the surface. Danielle, you had a great question. If one makes it and one doesn't, what you have to do is slightly change what you're doing. So let's say Alex does make the team and Eric does not. Well, check this out. We have them both accounted for, so 8 students is still 6 students, but instead of there being 5 spots, there's 4 spots because one of them actually makes the team, the other one doesn't, so that would be 6 choose 4. Do your box and fill. 6 times 5 times 4 times 3, divided by 4 times 3 times 2, and that would be 15 ways. So great question, Danielle. And no, it would not be 7. It would be 6 students left to choose from. Okay, everyone. Well, thanks for coming. Great question. I like that at the end, Danielle. That was perfect. And we will see everybody next week and fill out the feedback form if you can. So we'll talk to you next week.